Our catalytic converters. They are located before the muffler, generally speaking not too far after the exhaust manifold itself. The extreme heat in the converter oxidizes the exhaust. We've talked about this multiple times, about what gases are going in and what gases are coming out of our catalytic converters. But it converts an undesirable exhaust gas into harmless gases. So we're reducing exhaust noise with this also. It's something that we cannot just simply get rid of these catalytic converters. It is illegal to get rid of a catalytic converter. We cannot do that in a shop. We cannot cut that out. So we do need to know that if there's a problem with that catalytic converter, we must be putting a new catalytic converter back into that vehicle. We cannot simply get rid of that catalytic converter. That is illegal, and we do not need to be doing that. Here's a simple picture of a catalytic converter for you. You will notice that on one side of that we do see an oxygen sensor on the far side of that. On both sides of the catalytic converter we are going to see an oxygen sensor. So we can notice what is happening before and after the catalytic converter. Is the catalytic converter doing its job? Maybe it's not doing its job. Maybe we've ended up with a P0420 code. Maybe we've ended up with an efficiency code on that. So just because the code is there doesn't necessarily mean that we have a bad catalytic converter, but it is something to suspect when we look at this. So we can get out a 5-gas analyzer, or we can start looking at our data and start seeing exactly what's going on with these oxygen sensors. Very, very common to end up maybe replacing one of these catalytic converters. I will say that we try as best as we can we need to be getting the OE application converter on there. They are expensive, and I understand that. However, if we put maybe an aftermarket type design in, a lot of times they don't do the performance that the vehicle needs, so it might still end up throwing a code. It might take a little time, and it may not happen as regular, but it might throw a code for a P0420 catalyst efficiency code. So we want to stay OEM with that and put the OE parts in there if at all possible for a catalytic converter. The catalytic converter itself uses a 3-way part to this. It treats all 3 controlled emissions. The 3 emissions that we've talked about and we're putting into it are our oxides of nitrogen, which is our NOx gas, our hydrocarbons, and our CO to this. And what we're trying to send out now is going to be an H2, H2O, or CO2. So we're trying to take in these 3 gases and expel 3 completely different gases. Gases that aren't near as harmless to us as maybe that NOx gas that's coming in there. We have that NOx gas coming in. It's coming from that high combustion heat. We're trying to break it back down now. We're trying to break the hydrocarbon as it comes in. We have a raw fuel maybe that comes in, or a very small piece of a raw fuel that comes in, and we want to be able to break that back down once again. We want to be able to send it back out, and we want to get H2O out of this. We want to get something better out of it, and that's simply what our catalyst is for, and that comes back to we cannot be gutting these catalytic converters. It is illegal. A shop is not able to do that, and you as a person are not able to do that, so do not be doing any of that practice by any means. Common converter problems that I've noticed, often caused by overheating due to raw fuel entering the converter. A lot of times we may have had just a simple misfire concern, and now it ends up we fixed our misfire, but we noticed maybe it misfires under a heavier load now. And we found out, hey, we might have a converter bad. Well, that converter could have went bad because of the customer not fixing that misfire concern in the first place. I remember when we were talking in our computerized controls class about the check engine light flashing at them. So if the check engine light's flashing, that's a misfire that can cause a catalytic converter failure. So most likely, if you've had a converter that is destroyed due to overheating from that raw fuel, that check engine light was flashing at the driver of that vehicle. They knew that that problem was there. Plugged converter restricts exhaust flow. Function can be checked with the exhaust gas analyzer. So we could use our 5-gas analyzer to see exactly what's going. Or we could use a vacuum or back pressure gauge to check for restriction. It's very common to use that vacuum or back pressure gauge to check for that restriction. We can simply take out the oxygen sensor before the catalytic converter and watch and see what is exactly going on with the pressure. Do we see an unequal amount of pressure? We see way too high of pressure maybe with this catalytic converter. We could quite commonly see this if you had a V engine and you checked both sides. Maybe one side had 10 pounds of back pressure and the other had 1 pound of back pressure. That's common to see. So we had one side that had a really bad misfire and the other side didn't. So that one catalytic converter might be just fine, but one also might be bad. So we got to be careful, and we got to check both pieces to this. So we might see a GM vehicle that has misfires only on bank 1. Only on bank 1 is that problem actually happening. So I might lean to starting to look at just that bank 1 catalytic converter. We want to look at that and see what the back pressure is coming out of it. The mufflers has baffles, chambers, tubes, and holes to break up the sound. There's two very common types of our mufflers. We could have a reverse flow, or we could have a straight through flow. Produces some sort of back pressure, which does affect the engine breathing. Some back pressure is good. We do not want a ton of back pressure, but some back pressure is good. And looking at the two designs here, we have a backflow here and we have a straight flow. So if we're looking at something where we have a backflow up on our top, so we can see that the exhaust gas is flowing through. Now it has to go through. This is a block off, so it can't just move through. It has to go backwards and back into this. And once again, backwards, and once again, goes back and keeps moving back out. So it's there to break up the sound. We're going to have a fiber mat material in each one of these, so we're trying to break up that exhaust sound. Now, adversely, we have our straight flow. So we're going to be able to move the exhaust gas all the way through that muffler. Now we're going to have a glass matting most generally around this, and these holes are going to be in it so that it keeps blowing this exhaust gas into that glass mat, therefore getting rid of some of that sound. So we're going to get rid of some of that sound if we have this type of muffler. We're going to see something quieter up here most generally than we would see down here. However, both can be very, very quiet mufflers. But like I said, most generally, this is our OE application also versus our aftermarket maybe application such as your guys' maybe a glass pack or something, maybe a performance type muffler. The resonator, it acts as a second muffler or silencer, but it simply does further reduce the exhaust noise. It looks very, very similar to what you guys would see as a straight-through muffler, a smaller straight-through muffler. We do see these quite commonly in the exhaust system to bring exhaust noise back down. The customer does not want to hear that noise. They do not want to simply hear that exhaust noise, so they're trying to quiet it down maybe with a resonator. Our tailpipe, it's generally speaking the last pipe in the system. It releases exhaust gases beyond the back end of the vehicle now. Not to be confused here with the muffler. A lot of people commonly say, well, I need a tailpipe. A tailpipe is not a muffler. A tailpipe is the last pipe in the system. The muffler does not necessarily have to be the last pipe in the system. So do not confuse the two. Maybe the tailpipe and the muffler are as one, but in that case you would have a muffler tailpipe. So you got to be able to tell the two between the difference. So if you call and just call to your local parts store and say, hey, I need a tailpipe, they might be thinking you truly need a tailpipe. You don't need a muffler. So you need to be specific on the two that you're actually talking about. Exhaust system service. Any physical damage can result in partial restriction or blockage or leaks. You guys can have result in loss of power or backfiring even. Exhaust restriction causes increased noise and emissions. If you guys have a catalytic converter that's bad, this can result in something such as that can result in loss of power or backfiring also. So it's just different things that are out there that we do notice with exhaust system problems. Maybe it's as simple as a tailpipe, not a tailpipe, a muffler that has a problem. Maybe it's broken inside, and the baffling is not letting it flow through. We could see loss of power. It's not being able to expel all of that exhaust gas. So we could see that simple problem right there. Exhaust leaks. We need to look. It's sometimes difficult to see some of the stuff, but we can notice that little black line right here. We can notice that exhaust is simply broken. So once again, coming back to we were talking about different leaks earlier, we could actually test and try to find leaks. We might hear a small leak. We can test that and find that with our smoke machine. So if you guys want to get the smoke machine out and plug it into the back of the tailpipe, you guys could actually plug it and see what is actually one of these little pieces might be seeping right here. We can tell that. Maybe it's a hairline crack in that cast iron manifold, that exhaust manifold. That only happens when the vehicle is cold, because as that vehicle warms up, it expands and we don't hear that problem. Maybe it's a GM truck that has one of those exhaust manifold bolts that are broken in the head that we notice maybe on cold start, but we don't notice it as much when it's actually running and it's warmed up. Quite common to see those types of problems. So that smoke attack kit can help us find that, because we don't have to be running the vehicle. We don't have to be letting it warm up. We can put that smoke machine on there and see exactly where it's smoking. Inspections for exhaust system, look for holes, road damage, or split seams, kinks, dents, discoloration, or rust, broken or simply missing hangers, or loose tailpipes or other components. One thing I definitely want to mention is the rust part to this. It's under our vehicle. It's made out of a not-so-good steel most generally. We have that problem. A lot of times we will have rust problems with these vehicles, so we have to watch over that. Improper repairs that we could be talking about right here are some of these welds. So we have welds that we could be having problems with. The weld itself, we could be seeing, as such as we're seeing right here, you guys can see that's not a proper weld by any means. If we can't do the proper weld ourselves, have somebody do the proper weld, this being taped or zip tied around it does not fix a leak. You can't fix stuff like that. You need to be able to either weld the vehicle properly, and if the metal is not able to be welded properly, it needs a new exhaust. It's as simple as that. We need to be able to go from here all the way back, or from wherever we need to be, all the way to the back. If it can't be welded, maybe it's something that needs to have an exhaust clamp or a band clamp around it. Either way, we cannot be just globbing welds onto stuff and praying for the best. We need to be able to make sure that we have the weld properly on there, or we need to be replacing the pipe or put the proper band clamp around it. Exhaust restriction tests. If we're doing any restriction tests, we could, like we were talking about earlier, we could use our manifold gauge to that. We can bring up RPM a little bit, so maybe 2,000, 2,500 RPMs, and watch the gauge. Find the specification on this. You should only see a couple pounds of back pressure with this. Maybe as we goose the throttle, we rev that throttle really far. We might be able to see a spike in pressure for a second, but it's going to want to drop back down. If we see something where 5 pounds or up consistently, maybe even at idle, we see that we're having a problem with it. So we need to be able to simply just watch that gauge and see what's going on and compare it to what we know is good. Heating. Induction heating, as we see on the right side of this picture here, is very safe compared to our torch. It does help quite a bit, so we can see we have a bolt or a stud going through right here. We can use this induction heater to heat up just that one spot right there. So it's very, very common to heat only just that one spot up, so we don't have to heat all this and distort that rest of that material up. So if we can use an induction heating to heat it up, that's good. If not, we can use our torch. It's very common to be using our torch, like I said, on our exhaust systems. But if we use this, we're limiting the heat to that one component that is being heated up. So we don't need to heat all the rest of this up, as versely what we would see with our torch will end up heating this whole thing up. We're just going to heat that one area up right there. A torch may be needed to heat up or cut the exhaust, so just keep that in mind, and obviously we would in some sort maybe need a Sawzall for that also. That is simply all I got for you guys. I hope you guys have a good time with this, and I hope you guys do great on your test. Thanks a lot, guys.